All right, welcome back, everyone. We're gonna kind of resume here, starting to talk about sampling distributions, just as kind of like I don't know, whatever word of warning or word of caution or whatever. Um, this is typically kind of a hard concept to wrap our heads around because it's a little bit abstract. And so just kind of keep that in mind and realize that it might take a little bit of work to really understand what a sampling distribution is. Before we actually get there, though, we're going to talk about a few definitions that are going to help us think about sampling distributions a little bit. And so we've got four definitions here, so we're going to run through them, and then on the next video, we're going to see how they would show up in like an applied problem. And so if they don't completely make sense yet, hold on and wait till the next video because I think they'll be a lot more clear with an example. And so our point estimate, we're just defining this as like our best guess, and guess like we're still using data. So I'll put guess in quotes, for an unknown population parameter. And so that kind of leads directly into this next definition. So it's our best guess for this unknown population parameter, but what's a parameter? A parameter, and both of these sound more complicated than they are. A parameter is just some number, and so maybe it's like a population mean or a population proportion. So a single number that characterizes up the population of interest. And so remember, your population of interest is really defined by the researcher. And so you might be interested in maybe how SLU students respond to something. And so students at SLU would be your population of interest. You might be interested in how American adults and their drinking habits. And so then your population of interest is all American adults over the age of 21. So it's your population of interest is usually defined by the research question. And so a parameter is usually unknown. Remember when we talked about sampling techniques, the only instance where this would be known is if we actually had a census of our population. So sampling uncertainty is really the key definition here. And so sampling uncertainty we're defining as how much a point estimate will tend to vary from one sample to the next. And so this is also sometimes called sampling variability. And so right away we see this word variability, so we spent a lot of time kind of looking at the standard deviation as a measure of variability, and that will pop up again here. And the last definition is bias, which we talked about a little bit before in the context of sampling, but it's still relevant here, so we're going to define it again as just the systematic tendency to over or under estimate the true population value. And so just to kind of connect this to stuff we did at the very, very beginning, you could kind of recall that a convenience sample could be biased if it wasn't representative. But when we had like a simple random sample, that was usually, or that's almost always good, in that it's not going to introduce any bias if we're just randomly selecting people. If it's a convenient sample, then we just have to kind of think a little bit harder. Okay, so we'll stop here, and on the next video, we'll kind of see examples of these, which I think make the definitions a lot more clear. The definitions, like I mentioned before, I think they, especially these first two, they sound harder than what they actually are. So we'll see some examples of that in just a sec.